In today's video, I would like to share with you a very nice and interesting geometry problem that was suggested by viewer. Here is the following picture. We have A, B, C, D as square. We have this point E belongs to the segment AB, and also we have the point F belongs to the segment AD. We have this line FC and FE are perpendicular, okay? So our question, we are going to find this distance x, the capital AE, as a maximum number can take, okay? So what happened in this problem? So F is moving along the segment AD, making this distance x is increasing and decreasing, okay? So the movement of this F is related to this x, okay? While you keep this line and this line in perpendicular position, okay? The problem we are going to find what is the right position for F in order to get the maximum distance of x, okay? Because like this, we don't know where is F exactly. Take a look in this picture. I'm taking F in the middle of the segment AD, as you see it here in the picture. Now I'm going to change this F to another position. If now F become a midpoint of the segment AD, I'm going to decrease this distance behind, okay, to see what's giving us. Let's do that. Now we have decreased the distance of F by this distance. Now it was the half of the segment distance. Now this distance becomes smaller, okay? So what's giving us? It's giving us this distance x is smaller than the original one, okay? This time I'm going to move over F prime to this interval from A to the F by increasing the distance of df, okay, to see what's giving us. Look what happened this time. Even though I'm increasing this distance by taking df prime as a big distance, we don't get to the original distance which we have when F was in the middle. So whatever you change, notice the point when it was F in the midpoint of the segment AD. Okay, so this information is telling us we get the maximum distance of x while x is moving along the segment AB. It's taking the distance as a maximum value when F is a midpoint of the segment AD. Okay, now I'm going to raise this one to get a new picture of this one. Then we solve our problem. Okay, now the F is located at the midpoint of AD. That means this distance, since we have the segment, since we have the side length of this square is 4, that means this distance equals 2, okay? I'm going to draw a new line from the point F to the point B, and draw the second line from the point E to the point C, okay? I'm going to name this distance EC as a Y, FC as Z, okay? Now, if you take a look at this little triangle, EFE, as a right triangle, so now I'm going to apply the Pythagorean theorem on this small triangle. I have this distance EF square equals this distance EF. We found out it was 2 because F is a midpoint of the segment AD. So 2 quantity square plus this distance, which is x squared. Now I'm going to find EF. If you take a look again in this triangle ECF as a right triangle, because we have 90 degree here, so I'm going to apply the Pythagorean theorem. I'm going to apply the Pythagorean theorem on this triangle as well. So in EFC triangle, I have this distance y squared equal this distance z square plus EF square. Okay, I'm going to take this EF square and replace it into this equation. Okay, so I will get y square equals z square. This EF square equal to this one, which is 4 plus x square, 2 quaternary square plus x square. Now I'm going to move over z square to the left hand side of this equation. I will get y square minus z square equals x square plus 4. Okay, so here is a nice expression in terms of x, y, z. Okay, so now I'm going to calculate y square and z square. In order to calculate y square, I'm going to take this triangle EBC and apply the Pythagorean theorem on this triangle. So in EBC triangle, I have this y square equals this distance, which is 4 quaternary square, plus this distance. This distance equal to the whole distance, which is 4 minus x quaternary square. Okay, so we'll get 4 minus x quaternary square. So I'm going to calculate I'm going to calculate z square by using this triangle FCD as a right triangle. Okay, so in ECD triangle, I have z square equals this distance, which is 4 quaternary square, plus this distance. F is a midpoint of the segment AD, which is 2 quaternary square. So we'll get here 4 square, which is 16, plus 4 is 20. So now I'm going to take the difference of this one. I'm going to take the difference of these two equations. I will get y square minus z square. By taking the difference of these two numbers, I will get 4 quaternary square, which is 16. 16 minus 20 is giving us minus 4. Okay, minus 4 plus this term, 4 minus x quaternary square. Okay, now I'm going to take this found fact and replace it into this equation. So this one is giving us y square minus z square, which this one, which equals to x square plus 4, equals to this one. Okay, equal minus 4 plus 4 minus x quaternary square. Now I'm going to make some now I'm going to simplify this equation. So I will have x square plus 4. This one is giving us minus 4 plus 4 quaternary square, which is 16, minus 8x plus x square. Okay, so I'm going to take this expression down here and simplify the equation. I have x square plus 4 equals minus 4 plus 16 minus 8x plus x square. So I will have x square be cancelled out with this x square. By moving all over these terms, I get 4 on the left hand side plus this 4, which is 8. 8 minus 16, I get minus 8 equals to minus 8x. Okay, so this one is giving us x equals to 1. Okay, so I found the value of x now, x equals to 1. So I have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching, and we'll see you next video. Bye.